That's good. Okay. Oops. How can I go back? Yeah. Just testing everything works fine.
Make sure it works.
Yeah. Okay. Good afternoon, everyone, and welcome to our presentation. Today I will be talking on behalf of JCU, where I'm from, and Alex is from AutoWeed, and we will be discussing what is our technology and how we are targeting weeds in sugarcane farms. So first of all, just want to talk about the problem. I'm pretty sure you all know about the problem, but just to reiterate the problem. So as you know, as part of the Reef 2050 water quality improvement plan, we need to just reduce the runoff so that by then 99% of the species would remain unaffected. So for that to happen, we thought, okay, what can we do? What sort of practice change, what sort of innovation can be happening so that we reach that target, that goal? And for that, we think we have a solution. What is our solution? Our solution is a smart spot spraying compared to blanket spraying. That is, I think, current practice. So this is a win-win solution, because not only the farmers would save cost by saving herbicide cost, it will be also a win for the environment and the GBR through reduced herbicide, because if you only put the herbicide where it should be put, then you're having less runoff to the reef and then less environmental impact. And this is the technology that we have developed. So we call it AutoWeed. This technology was developed as part of Alex's PhD project that I supervised at JCU. He worked on that project for 4 or 5 years. He developed this excellent modular design during his PhD, and we are really proud of this product. And today, okay, we will be talking about this, and I thought it's best that Alex talk about this technology that he recently set up a startup for. And he's recently we got this grant from the Great Barrier Reef Foundation to develop this AutoWeed technology for sugarcane. And I think I'll hand on to Alex from here, and he can talk about the AutoWeed technology.
Yeah, thanks, Mustafa. Yeah, so this was a PhD project that I started in 2016, and so it's a long process till now. We basically had strong results working in about 5 different trials across Queensland at the end of my PhD, delivering in pasture and in crop situations. And that success led us to begin a startup organization based in Townsville, which is cool to see the technology there. And we've been applying these systems for growers in pasture and in crop. Previous technology for spot spraying you may be aware of is Weedits and other near-infrared based sensor technology, and that's limited to only applying in fallow situations where near-infrared can only pick up all living green things, basically. We use a different technology that allows us to detect weeds in a grass background, in a crop background like sugarcane, and this technology is really sort of starting to take hold. There's more competitors coming up in the US and the UK, and we're proud to be sort of the Australian force behind this. And we've had basically 6 years experience delivering weed detection systems. And so this one right here, this is our 3-meter system that we delivered as part of a Smart Farm Small grant with James Cook University, targeting Harrisia cactus in pastures in Goondiwindi. Now, this is really drought-heavy region, and the cactus is very easy to spot. It stands out very, very much so. So we trained a model to detect cactus in the field and deployed it on a 3-meter system on a John Deere Gator. We've built this system, the AutoWeed system, to be modular, so that we can basically attach it to any boom, whether it's an ATV, UTV, 3-point linkage tractor, or a high-rise sugarcane boom. The main process was to basically get the response time that when it sees the weed to be fast enough so that we could drive that vehicle in a real-time application. So in pastures like this is targeting the Lewis sedge and the African tablelands. This is a very difficult weed to spot in the pasture, because sedge, as you know, it's kind of like nut grass. You have to really have a good eye for it. And even the farmer's going to miss probably 10% of these weed targets. So we're able to detect this with up to 95% accuracy. So it's actually going to be better than the farmer. And that's the response we get from our growers when we deliver the system. It's like, oh, it's doing a better job than my guy's spraying. And once we reach that, we knew we were. So thanks very much. Is that working? Yep. My voice might carry anyway, but what? Oh, it's full of live stream. All right. So once we reached that point, we knew we had something that could be effective. But the real challenge was that real-time speed. And as you can see, this is just a nice demo of the real-time speed. And Mustafa has helped us with JCU to achieve that speed so that it's actually useful for farmers on a variety of vehicles. So that was actually the world's first Navua sedge green-on-green system. So that was exciting to deliver that. This here is a crop trial. While we're down in Boggabilla, Gundawindi region, it's a large grains grower there. So we were able to use the exact same vehicle in the first video on a crop, in their crop. So he has tons of, this is Willaroo, Warrakiri cropping, a national cropper. We were able to quickly take the vehicle over a wheat crop, and that's milk thistle. And crop is actually even easier than the pasture situation because of the homogeneity of the crop environment. The background looks bloody a lot more regular and consistent, and so the weeds stand out like dog's balls, honestly. It's a lot easier to detect, and we can achieve higher accuracies in crop than we can in pasture. Yeah, so how does it work? I guess that's the big question. We utilize computer vision, which is just a fancy word for a color camera. So your standard camera like in your phone. Visible features. So for weeds, that is color, shape, and texture that separate it from the background environment. So this is very difficult if the weed looks identical to the target environment. So if it's a challenging weed, you can't get as good of accuracies as you can as an easy weed. You can actually, it just takes longer. It takes more images to be able to train it to do that. So it varies depending on the application you're in. Fortunately, crop is actually quite good. But yeah, it requires thousands of images. So the key technique we use is called deep learning, and that's what Facebook uses to detect faces, and your phone also uses it. So it's a very dominant technique, and that's really opened doors in the last 5 years for this technology to take off. But yeah, it requires thousands of images of the weed and its neighboring background. You have to have a human expert then say, the weed is here, the weed is not here, the weed is here, the weed is not here, for about 1,000 or so images. And then you're able to train the model to detect the weeds in a real-time situation. You don't have to cover the whole crop with those images. You just have to cover a small section, and then that will hold for the rest of the crop paddock where it looks similar to those images. So data set collection is a massive part. And what we're doing at AutoWeed, we started the company in 2019. It's myself and some of the people that were responsible for the work at JCU when we were sort of getting it off the ground. We're based in Townsville. A big part of this is going to have a head office in Townsville. Whenever we install a vehicle on farm, it's going to have a remote connection to our office so we can download images from the field, train our models in Townsville, and upload them to the tractors, basically. So internet connection does help. Otherwise, we'll have to look at sort of certain, like Gundawindi, obviously. The internet connection there is not that great. So there's a bit of travel back and forth, or we have to work things out. Internet does make things a lot easier for us. Fortunately, for the work we're going to be doing for the GBRF, it's in the Burdekin, it's close, and Phil Corica is our partnering farmer, and we're going to install internet connection on his vehicle permanently throughout the project, which would be really cool. So a big thing is the effectiveness of AutoWeed. So we've done a few trials on those videos that you've seen before. We were able to do a herbicide trials on Navua sedge in pasture, on Harrisia cactus in pasture, and milk thistle in wheat. So the herbicide of choice, for the same as for nutgrass and cane, is, oh sorry, I've gone back. There we go, is Sempra and Banjo. This was the target priority because Sempra costs almost $100 a hectare. Like, it's bloody expensive. And that's going to be the main reason we're targeting that in cane. That's our first point of call, is to solve nutgrass in cane. But for Navua sedge, so the vehicle takes about the same amount of time when you're doing spot spraying versus you're doing blanket spraying, because the vehicle has to cover the paddock. But we really do see the cost in, if you have a weed infestation that's about 10% of the paddock, you're going to save 90% of the herbicide. That's just how it works. So it really does depend on the level of infestation in your paddock, but they're the results we're seeing. Harrisia cactus in pasture was a little bit different. They don't perform blanket spraying, they instead perform hand spraying. So what we're doing there is we're saving 50% of the time to actually spray compared to hand spraying. The herbicide cost, it's only saving about 37% of the herbicide. So for Harrisia cactus in pasture, it was more a labor and a herbicide savings that we're seeing, which was great. So those two vehicles are in operation. We're waiting for the wet season to take it easy on us up in the tablelands so that we can get the vehicles in the field. And down south, they've just had a bit of rain, fortunately, for the first time in a while. So, but yeah, and then milk thistle in wheat. So we did a small trial, and based on the level of infestation, we were able to save about 95% of the herbicide cost. But the cost of controlling milk thistle in the wheat wasn't too high on a per hectare basis. So a big question, as I was mentioning before, is getting the speed up. For sugarcane, we have to be at about 15k an hour, or we're not going to make much of a difference for efficiency. So fortunately, JCU, they've been a massive partner to help us with new algorithms to be able to get our speed where it needs to be for sugarcane, because previously we only operated at 10 kilometers an hour. So this is a new speed requirement for sugarcane. And I'll hand off to Mustafa, who's really headed the research to be able to get that high speed.
Thanks, Alex. Yeah, as Alex mentioned, we are helping with developing the system, with the deep learning part of things, and also with improving the speed of the hardware that is required to detect the weed when it sees it, because we need that to be fast to be effective. Okay, that brings us to this point that we recently received this funding from the Great Barrier Reef Foundation as part of the Water Quality Innovation Program. JCU is leading this grant, and we are partnering with AutoWeed and also Sugar Research Australia. So what we want to deliver there is we want to reduce the knockdown herbicide usage by 80% at least. So that's our target, and we want to see how effective is this herbicide reduction. That's why we partner with Sugar Research Australia to help us evaluate the reduction in the runoff to the Great Barrier Reef. So this is the overall aim of our project, but we have started this project in November, December last year. So we are still in the early phase. So the main three goals of this project are: we want to deliver 15 AutoWeed detection units for a 4720 John Deere sprayer. This is Phil's machine. And we want to actually just retrofit AutoWeeds, and I'll show you in the next slide how we fit it with our detection units. And as the next step, we want to detect priority grass and broadleaf weed species in cane. So the farmer will tell us what sort of weed they need to treat, and then we go and train our algorithm based on those weeds, and we run it on the farm. With this project, we have limited, basically, trials that we can do, but our hope is we can cover as much as we can. And then, of course, at the end, we want to see what is the effectiveness of our method in reducing the herbicide runoff. So, as part of the first phase of the project, we have developed this, AutoWeed has developed this beautiful design that can be replaced in the same place that an Irvine leg is placed on this 4720 vehicle. I took this photo when we had a meeting with Phil in GRU. I think it was in November. So this shows like how AutoWeed can be retrofitted into different machines. So it's so you don't really need to go and buy a new machine. Our detection and spraying unit can be retrofitted. And this is exactly the demo that you see here. So the nozzles are there, the detection unit is there, so we have to collect images, and I'll show you a bit more about that.
I might just add a point on that too, Mustafa. If you go back to that figure, you can tell it looks quite a bit different to the demo there. The reason being, and one forward there. We were hoping to be able to retrofit into that John Deere sprayer, but it's quite difficult to place the detection unit between the vehicle and between the sprayers for that system. So we went with the alternate route of Phil Corica uses Irvine legs for late stage cane spraying. So we had those slots there, and we thought that was a viable alternative to build a system that could slot into those Irvine legs. The AutoWeed detection units can still be taken off and put on any vehicle. So we've made them modular, and especially that's the case if there's a failure in the field, you can pop off a unit, you got a spare, pop it back in. We're trying to make them sort of retrofittable, modular, so that the farmer can get on with his job. So that's some of the things that went into that design.
Thanks, Alex. So yeah, to just give you a bit more about, like around last year, around this time, we started saying, okay, so even before we get the grant, we wanted to see how effective is our method. We wanted to collect some images because Alex mentioned one of the needs for deep learning algorithms to work is to just train them with many, many images. And again, we asked Phil, and he helped us with collecting like images, 33,000 or over that number of early cane in groove with with nutgrass and volunteer soybean. And we collected all those images. Alex and AutoWeed, they have developed this nice software that you may say, okay, I don't want to go over the 30,000 images to one by one. You don't need to do that. You have to just tell us in a handful number, and then we will figure out the rest. And it's much faster than you would think. And then what we did in this case, we said, what is negative? Negative here is cane. We don't want to touch that. We want to see soybean, nutgrass, and soybean and nutgrass because they both may be in one place, right? So, and then we feed these to our algorithms, and with this we were able to just have a really good detection accuracy of around 90%. And we developed different machine learning or deep learning algorithms and did a bit of research of which one is better. And this shows our accuracy is good enough to basically target nutgrass and soybean or any other weed, you name it. So how fast we could do it, Alex showed that in order for the vehicle to be able to reach 15 kilometers per hour, he needed us to give him like a detection accuracy of 48 milliseconds. We reached the best speed that we reached for detecting a weed in an image is 32 milliseconds. And that's again with those names that you see are here, those are different deep learning architectures that we know better, and you don't really need to care about that much. It's just the brain behind this machine vision algorithm. Again, it's fast enough to reach our goal. And okay, what is next for this project? We have a lot to do. It's a 2-year project, and we have planned our project. We have changed it a bit so that we can cover different stages of growth for cane, different weather conditions, and we want to do several trials across perhaps hopefully in different areas and with different weeds, and for each of those we have to go and collect the images, rerun our algorithms, and basically train our AI or machine learning for any weeds that the farmer needs to be treated. And then other thing is we will collect a lot of data. And for each trial, we will talk about, okay, we will see how effective is the system, what is the herbicide cost and usage, what is the time taken, and all the other parameters, and they can be taken into account. And of course, one of the things that we were thinking about, okay, what comes as a byproduct, as a side thing that we can use is we can map the weed infestation in areas, because we are collecting it and we have a GPS on the vehicle or on our unit, and we can see where the weeds are and have more information. So in conclusion, so you saw that we have developed this AutoWeed technology that Alex has put his heart and soul in the past 5-6 years in it, and I have been helping with this. So we are hoping that this would help really solve an industry problem. So this has been applied to both pasture and crops, and has shown good performance, up to 95% herbicide reduction. So currently we are working with AutoWeed and SRA to see if our win-win situation is really a win-win situation. Is it really going to work when we go and see all those variables that come, the weather conditions, the irrigation, and all the other scenarios. So that's the part, those are the questions that we want to get answered. But our hope is our project will reach that stage that we can say, yes, we have saved the farmers some cost and also helped a better, healthier reef. And thank you. If there is any questions, Alex and I would be happy to help.
We can take a couple of questions, but you will be able to move into the other room once the presentation's concluded to have a look at the model, yes? So, Joe.
Scenario, hire a company that hires equipment out on dry hire basis, meaning the farmer has to do the work, but the equipment being hired out. How much do you envisage will be your involvement in that process?
So leasing the product out.
Basically hiring.
Yeah.
So a farmer can do a paddock. So,
Right.
you know, obviously you've got the cost of new technology.
Yeah.
Not every farmer's going to be able to buy that and just ride in the backyard.
Yeah.
Whereas hiring, you might be able to do that. But is there a need for this learning aspect?
Yeah, so that's what we're establishing now because we're commercializing this technology. It's not yet commercial. We're making it commercial. So we're working with early adopters at the moment. So spray contractors is one avenue we've chased. So we don't really like the idea of leasing it out. We've heard Swarm Farm is one group that's leasing out their robots for usage, their autonomous vehicles. We've gotten some bad feedback from growers who you know, I put in all this leasing, I pay 75 grand a year for a Swarm Farm system and I don't own any of it and it could be off my paddock, my farm the next year. So the feedback we're seeing from growers is, yeah, spray contracting is useful, but in the tablelands region and maybe even sugarcane region, if it's weather dependent, when the weather says go, there's only one vehicle, it's not going to be able to treat multiple farms. So we're going to work with early adopters to get the vehicle through the commercial stage so that we can solve the problems, and then we're going to make it as best as possible to roll it out on the other side. So the data set collection, we're establishing that right now in Townsville to get the workflow to be smooth, and it looks like it will be able to be delivered on a product basis. So if you buy it, you'll have to buy the remote connection to your farm, and we can deliver the data throughput to address each individual product.
All right, so we'll have to move on to one more question.
Thanks very much for that presentation. I thoroughly enjoyed it. Just one question. The 15 kilometres an hour is a target, I know. Just looking from where I am, why do we have to go so fast? I mean, I got cattle pastures and cane. I believe that 15 kilometres an hour would be on the top end. If we as farmers are going to save on labour input and other inputs, I believe the speed could come back. Perhaps your technology could work at a better and it would be more practical. I just want to know why we're chasing such a high speed.
I guess because our early adopter is a spray contractor and I guess he's busy. He's spraying quick. But yeah, no, that is a fantastic point. Like if you are happy to work at a slower speed, it makes our technology a little bit, you know, gives it a bit of breathing room. That's beautiful. We don't have to strive to get new technology to get that speed up. But I will say that we have some interest from broadacre croppers in New South Wales, and they operate at 20k an hour, you know. So the need for this technology on a national level demands higher speed. But I've also talked to a lettuce cropper in Victoria, and he's happy to move at 1k an hour. That sounds good to me. So right now it's just we have an acceptable that we can deliver to, and we're comfortable up to 10k right now. And if that's the case, then hey, that's great for us. But we are getting a bit of demand to go faster. But yeah. Yep. Yes. Yep. Oh no, that's. I love to hear that. So
All right,
that means we're ready.
We do have a schedule to keep to, and these guys have to move room with their robot. If you'd like to talk to them further, I can shift you into the other room, and you guys can talk one-on-one before they leave. Please thank Mustafa Rahimi Asghari and Alex Olsen.